Hi ladies, in this video we're going to go through the solutions to this worksheet. So these questions are actually quite challenging from memory. I took them from a Year 11 Methods textbook. So if you found them hard, just remember you're just starting parabolas and quadratics. So it's highly likely you are going to find them challenging, and that's why I put challenging on there, just to remind you that they are hard. But also it's always good to challenge ourselves. So there's no point in always doing easy stuff, because then when you do come across things that are hard, you're like, oh, I'm dumb, I can't do it. But that's not why I give you challenging stuff. I give you challenging stuff for you to really push yourself. Okay, so I often like to use the idea of running. So I like running. One day I'd really like to run the New York Marathon, probably not at the moment because, coronavirus and everything. But, I'm determined to get there, and that's my challenge. And at the moment, I probably couldn't run 5 kilometers. I used to be able to run quite a distance, but, with these cold days and dark nights, I don't feel safe running. I also probably don't really want to. I might just be using that as an excuse. I actually joined a gym over the break, and my membership lasted 5 days before gyms closed again. So, the thought was there. Anyway, you don't need to know that. The whole point is, girls, you need to challenge yourselves. Don't always expect things to be easy. And if they are easy, you need to think, well, is this really helping me? I probably need to do something a bit harder. All right, so question 1. The diagram shows a masonry arch bridge of span 50 meters. Okay, so nice, they're giving us a diagram. The shape of the curve ABC is a parabola. Okay, so that red line. The line AC is the water level. Okay, so clearly shown. And B is the highest point of the bridge, which is here in the middle. Okay, so it's going to be our turning point. Okay, question A, taking A as the origin. So origin always means 0, 0. So if we were to graph this, A is 0, 0. And the maximum height of the arch above the water as 4.5. So this point here, H is 4.5. Write down a formula for the curve of the arch where Y is the height of the arch above AC and X is the horizontal distance from A. Okay, so we're dealing with the variables. So let's write them down now. So Y, it's like, what are they? Y is your height above of the arch. So a height above sea level. Or height of the arch, which I probably should have written, but I already wrote the word above. So, and then X is your horizontal distance from A. That just helps when we're referring back and we're like, oh, what are we doing? Horizontal distance from A. Now, as you do a lot of this, maybe more also in VCE, we don't tend to use X and Y. We would probably use H for height and D for distance, something like that. So just keep in mind, you need to, if you're given variables, so if they were using H and D, you need to use H and D, especially in your answer, because if you wrote X equals, well, X was never defined. So, yeah, so you always try to stick to the variables given. All right, I'm getting distracted. So what information do we know? We know our A is at 0, 0. Our turning point is at, now it told us, is at 4.5. That's our height. And it's a halfway. So halfway of 50 is 25. Okay, so we've got that information. And if you want to do C, C is at 50, 0. Now, when you're writing down, what do we have to do? We do have to write down the formula. So it's going to be Y equals. Now, you can put in, you can do it several ways. I would probably, because we know what our x-intercepts are, I'm going to do that. So I'm going to write A because we don't know what that factor is for the parabola. And then our two other factors are going to be x plus 0, which we probably didn't need to write, but the other one is x minus 50. Okay, so positive 50 here is your x-intercept, but when we write it as a factor, it's x minus 50, because remember we let that equal 0, and that's how we get that positive 50. So let's just expand this. So it's going to be x squared minus 50x. Now we're going to substitute in that turning point, so 25, 4.5. So we got 4.5 equals a 25 squared minus 50 times 25. Now I said to a few of you, in VC you'd probably do this by hand, but you can use your calculator to do this. So let's get the calculator up. Might just make that a little bit smaller. Okay, so we just want to do add calculator. It's going to be a solve. 4.5 equals a. Now sometimes your calculator doesn't like a by itself, so I'm going to put a times in because it is effectively a times. 25 squared minus 50 times 25, and you could have done all that on the computer, but anyway. Whoops, comma a. So a is equal to negative 0.0072. All right, so I was just actually looking at the answer. Sorry, I'm doing that. I forgot how many zeros we had. 0. So you could have done this using the turning point form as well. 7.2 and x squared minus 50x. Oops, it's not a, sorry. I just keep pausing to check the answer. So this is fine. There are many ways you can actually write this. The answer on this sheet has actually put x out as a common factor. So just taking x as a common factor here, which is perfectly the same thing. Okay. And you could have done it in turning point form if you wanted to. Okay, let's look at question B. Calculate a table of values and accurately plot the graph of the curve. Now you can do a table of values on your calculator. So I'm going to do that with you because I don't think have we done table of values at the start of the year? I can't remember. So if you go Control T, oops, no, let's graph it first, sorry. Let's add a page, add graphs. Okay, so we're going to put the equation in first. So negative 0.0072x times x minus 50. Oh, what's wrong now? I don't think, is it the times there? Okay, so we can't really see it at the moment, but we can actually set up a table of values. Now, can we do Control T now? Will it do it for us? Okay, so here's your table of values on your calculator. So all I did was Control T, so you've got that here. Now, you're going to have to sketch it, so you probably don't want to do 1, 2, 3, 4, because we're not really getting big numbers. So you can do maybe multiples of 5 or 10 to help you do that. So if we just go to Menu, Table, Table Settings, so we can start at 0, but let's go up by 5. Okay, so that might make it a little bit easier for you to sketch. So you can see that your turning point looks like, oh, it is at 25. So that will help you sketch it. So you can just sketch all those points to help you sketch the graph. You could even go up by 10 if you want. If you went up by 10 though, you'd miss that 25. So going up by 5 is probably good. So just so you know what I'm talking about. Oh, we need to add another page. Sorry. Okay, so when we're sketching it, you would have your x-axis, going up by 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And then you've got these values on here. So I would probably go up by ones, 1, 2, 3, 4, and then we need 5 as well because the highest point is at 4.5. Okay, so our first point on the calculator is 0, 0. At 5, we're at 1.62, so about here. At 10, we're at 2.88, so somewhere around here. Oh gosh, sorry. 15, we're at 3.78, so somewhere around here. 24.32, and then we reach the top at 4.55, and then you're basically doing the same thing. Okay, hopefully you get the gist of it until we get back to 0 or 50, which should be there. So that's what it's getting you to do, to sketch your graph. So just plotting those points. All right, let's go back to the questions. D, oh, hold on, no. C, what? At what horizontal distance from A is the height of the arch above the water level equal to 3 meters? So you can do this on your calculator. Okay, so to get rid of that table, just press Control T again. And let's change our window because we can't really see the graph just yet. So I know that X has to go up to 50, so I might just make it go up to 60. And the scale, I'll make go up by 5s. And let's just make that go up to 5 as well. Okay, so there's your graph, okay, or the bridge. Now, if you wanted to do it on your calculator, we can just add another graph and we let that equal 3. So there's your height of 3, and you can get the intersection point. So if we go menu, analyze graph, intersection, so just go to the left, to the right, and there's the first intersection point. And then we can do the same thing for the other intersection. Okay, so there it is there. I forgot what the question actually asked. So let's go back. At what horizontal distance from A is the height of the arch above water equal to 3 meters? Okay, beautiful. So let's go back to our calculator. So at two spots at 10.63 and 39.4. Now you could also use solve. So solve, I need the equation, so let's just go scroll to get the equation. So negative 0.0072x, x minus 50, and then let that equal 3, because remember h equals 3, comma x. Oh. When it says implied multiply, just put it, so it didn't know to multiply that bracket by x. Okay, and this will give you a more accurate answer. So when you looked at the graph, it went to 1 decimal place. Here it's to more decimal places. So if your answer said to 2 decimal places, you couldn't just rely on what the graph screen told you. So it's always a good idea to come back here. I don't think the question said to how many decimal places, did it? Nope. Okay, so we'll just do it to 2 decimal places. All right, D, what is the height of the arch at a horizontal distance from A of 12 meters? So this time we're letting X equal 12, so that's a little bit easier. So I'm going to do that on the calculator. I know you can probably do it by hand, but I want to show you quick ways to do things on your calculator. So let's just go there and we can get rid of all of this. So get rid of solve, get rid of that bracket. Okay, so we've basically got our equation. We don't need the y equals part. So if you go control equals and this line, which means given that, and we want x equals 12, and there it is, 3.2832. On your graph screen, you can do it there as well. So you go to menu, trace, graph trace, and see down the bottom here, you can just type in 12 and the point will come down the bottom here. Okay, so it's given you to 2 decimal places, whereas this is given it to more decimal places. Okay, let's go back. This is where I think it gets hard. A floating platform 20 metres wide, so there's our floating platform there, is towed under the bridge. What is the greatest height of the deck above water level if the platform is to be towed under the bridge with at least 30 centimetres horizontal clearance either side? So I've done this question before. Let me just try to remember. Okay, so basically we want to find the height. So we got to find out what x is equal to. So the first x. So our, coming up? No. So there's our, what did they call it? Oh, sure, I'm always worried things are going to disappear on me. What are we doing? A platform. Okay, so the platform is 20 metres. Now it needs a clearance of 30 centimetres each side. So we've got to add on 30 this side and 30 this side. So effectively we need to have 20.6 metres. Okay, so 20 metres for the actual platform and then 30 centimetres each side. So when we're looking at our x-axis, we need to find out these 2 points. So if we divide this by 2, which is going to be 10.3, our halfway point on our x-axis, remember, was 25. So half of 50 is 25. So our beam has to go this way, 10.3, and this way, 10.3. So we're going to have 25 minus 10.3 and 25 plus 10.3. So 25 minus 10.3 is, what is that, 14.7? And this one here, we're going to have 36.3. And I can't remember what the question is asking us. What is the greatest height of the deck? Okay, so you didn't need to do both of them, just one of them. So we've got to find when x equals 14.7. So let's go back to our calculator. Okay, so I can scroll up. I like that. Delete the 12 and put in 14.7. So the maximum height, which is y, could be 3. Let's just do it to 2 decimal places, 0.74 metres. Okay, let's move on to question 2. Now it's lunchtime, so things might get a little bit noisy. Not in here, but outside. A piece of wire 12 centimetres long is cut into 2 pieces. So here's our wire. It's 12 centimetres. We don't know how it's cut just yet. One piece is used to form a square, and the other is a rectangle. And this rectangle, the length is twice its width. So if this is your width, the length is 2 times that. All right, so question A, if x centimetres is the side length of the square, write down the dimensions of the rectangle in terms of x. So you've got the perimeter of the square is 4x. The length of wire you can have from that, what's left over for your rectangle is 12 minus 4x. So we've already used 4x. All right, just have to look at the answers again. Okay, so we've got a perimeter for the rectangle in terms of x. Let's get the perimeter in terms of w. Now in the answers they've actually used a, but I'm going to stick with w. So the perimeter of this is going to be 2w plus 2w plus w plus w. Whoops. So we've got 6w altogether. So this is your perimeter of the rectangle in terms of x, and this is the perimeter in terms of w. So basically 6w is equal to 12 minus 4x. Okay, so we've got 1 in terms of w, one in terms of x. The question is asking write down the dimensions of the rectangle in terms of x. So let's get w by itself. So divide by both sides by 6. So 12 divided by, actually I might just factorize that. I was going to, all right, so let's take the common factor of 2. So we've got 6 minus 2x over 3. Now your length, so remember your length of your rectangle is equal to 2w. So your length is going to be 2 times that, which is effectively 6 minus 2x over 3. So we've got 12 minus 4x over 3. Okay, so they're our dimensions of our rectangle. Formulate a rule for A, the combined area of the square and the rectangle in centimetres squared in terms of x. So the area of your square is just x squared, so that's nice. Oh, someone just opened the door. Okay, so that's the area of the square, and then the area of your rectangle, which is just length times width. So we're going to have 6 minus 2x over 3. Now put that in brackets and then multiply your length, 12 minus 4x over 3. Now you could simplify that if you want. It just says formulate a rule. I mean, you can simplify that. I'm just going to leave it as it is though. And then C, determine the lengths of the two pieces if the sum of the areas is to be a maximum. So what you need to do is actually graph this. Okay, so let's put that into the calculator. Okay, if you've done other stuff, just go, you can either add a graph or you can just go to new. I always find it easier to go to new. Okay, so add a graph. All right, so let's type this in, x squared plus 6 minus 2x. Always check that your calculator is typing it how you want it. Times, well, see how I've put brackets in? So I've put brackets in this denominator as well. Not denominator, sorry, the numerator. So you can see I've done that on the calculator. Okay, and then what have I got? 12 minus 4x divided by 3. Okay, so here's your graph. We only need to find, what do we need to find? Determine the lengths of the two pieces if the sum of the areas is to be a minimum. So we want to find this turning point here. So menu, analyze, graph, minimum, and we just go to the left and then to the right, and we can move that. So we've got x equals 1.41 and A is equal to 4.24. Can't remember what the question is asking. The lengths of the two pieces. Okay, so we've got 1.41. Now, because it might want more decimal places, we're going to leave it as 1.41 now, but remember you can always go to, what was it? Calculus, function minimum. I don't know why people are coming in here. Is there something on at lunchtime? This is just weird. Maybe I should lock the door. Maybe they're looking for rooms that are open. Okay, so function minimum, and you can do it that way. Now, if you don't like copying things, you don't like rewriting things, you can easily just copy. So I've gone back, just highlight it. So we use the shift just like you do on your keyboard. Just highlight that, not the F1X equals, Control C will copy it. Go back here, Control V will paste it. That's not what I wanted. Let's go back. Did you see it? I had what I had before. Lucky I checked. Okay, now Control C. Better work this time. Beautiful. Comma X. All right, there it is as a fraction, and there it is as a decimal. Now, if you wanted the y coordinate, remember you can, and I've already copied it, so I should be able to just paste it now. Control equals given that, and then just highlight that and to get the y coordinate. Okay, so you can see the two of them there. Now, we had to find, so we've got x, we've only found x. So we found the dimensions of the square. So each side is 1.41. Then to get the dimensions of the rectangle, we need to use these values. So the 6 minus 2x. So again, you can just highlight. So remember, this is your width. So copy that, paste it, and then you can go control equals given that x is equal to this. All right, so that's your width. And then to get your length, remember it's just twice that. So we can just go times 2. All right, and that's your length. Okay, so x, 1.41 is the length of your square. Here, 1.0588 is the width of your rectangle, and 2.1176 is the length of your rectangle. Oh, and the length, so we had to do the lengths of the two pieces. Okay, so you'll just add them together, or to use your perimeter. Okay, I'm sure you can do that. I think I've done the hard part for you. All right, let's move on to question 3. Water is pumped into an empty metal tank at a steady rate of 0.2 litres per minute. After 1 hour, the depth of water in the tank is 5 centimetres. After 5 hours, the depth is 10 centimetres. Okay, so a bit of information there. So we've got it's being pumped into, okay, so it has the rate is positive, so 0.2 litres per minute. After 1 hour, so when t equals 1, although I think we've defined x as time. Let me just check. The volume, oh no. Okay, let's just keep it that. So after 1 hour, t equals 1, the depth of water in the tank is 5 centimetres, so the depth is x. Now, the volume we use t for because this is 1 hour. 1 hour, t equals 1 hour. Your depth is 5 centimetres. So your volume, if we just multiply 0.2 times 60, because it's 0.2 litres per minute. So after 1 hour, we're going to do 0.2 times 60. It's terrible, I'm just doing it on my calculator. Okay, so we've got 12, should have made that. And when 5 hours, so t equals 5 hours, x is 10. So your volume is equal to 60. So question A, if the volume blah, 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 blah is, okay, so we need to write a rule that connects, I can't talk properly, which connects those values. Okay, so the volume of the variables. So we've got V litres. Okay, so we've got two values. We've got when x equals 5. So we've got 512. And we've got 1060. So there are our 2 points. And at the start, because it's being filled, and it hasn't said that, it says it's empty. So that's our other point there, 0, 0. Okay, so Word just died on me. So we're going to start question 3 again. Okay, so I just need to write down the points. So we had 0, 0 because it was empty. What else did we have? When we had a depth of 5 centimetres, the volume was 12 from memory. Hopefully it's correct. And then 10 and 60. Now, there are 3 points. Because we're working with parabolas, we can write down the general rule of a parabola, which is V equals ax squared plus bx plus c. Now, because we know the point 0, 0, your equation's just going to be v equals ax squared plus bx, because your constant or your y-intercept is 0 anyway. So you can write plus 0, but we don't tend to write that. So we're just going to use v equals ax squared plus bx. So we've just substitute the 2 points in. So the first point, which is 5, 12, you're going to have 12 equals ax squared plus, Okay, substitute the a in, the x in, 5 squared plus b times 5. So that's your first equation. So if you want to call that equation 1. And then your second equation comes from the other point, 1060. So we've got 60 equals a 10 squared plus b times 10, and that's your second one. Now you'll notice the solutions for this, solve them using simultaneous equations, but you can just use your calculator. So we've got solve. We've got 12 equals, now 5 squared is 25, so I'm going to write 25a, and then we've got plus 5b. And the second equation is 60 equals 10 squared is 100, so 10a plus, 100a plus 10b. And we're solving for a and b. So there's our two answers. Now, because they're in exact form, I'm just going to press Control Enter to put them in decimal. So your value of a is 0.72 and b is negative 1.2. So in your equation, we've got v equals 0.72x squared minus 1.2x. So all I've done is substituted them back into this general equation. All right, it is known that the maximum possible depth of the water of the tank is 20 centimetres. For how long from the beginning can the water be pumped into the tank at the same rate without overflowing? All right, so let's have a look at what this graph actually looks like. All right, so if you want to start a new graph, you can. So let's just go to new graph. Okay, so remember, we're just sticking with x. We don't have to put v equals in, so x squared minus 1.2x. So why has it gone down? I'm just wondering if I put it in correctly. Okay, it's weird that it goes down before it goes up. Anyway, so what we need to do is first of all see how high the y scale. So we want to go, what was it, 20 litres? So let's do 25 just so we can see it. And let's add on another graph, so 20. So it's basically this point here. Actually, I feel like I've done something wrong because, let me just pause and check. Sorry guys, I was doing the volume of 20. So let's just go back and delete that one. Whoops. So we want the depth is 20, okay, not the volume. So let's just go change our window again. So we want our x to go maybe up to 25, whoops. And I'm guessing this is going to go quite high. So let's make it 250. Okay, so can you see it? I think I might just need to go a little bit higher. I might go to 300. Okay, so you can do it on your graph. So let's do it on the graph first, and then we'll do it on the calculator screen. So graph trace, we want when x is equal to 20. So it's 264. So when x equals 20, the volume is 264. Now remember that I think the question is asking for time. Now, let's let's just go back up because I was looking at the solutions before. How long? Okay, so we know it pumps at a rate of 0.2. Okay, so we take the volume, so 264, and divide that by our rate, which is 0.2. So we get 1320, and that's in minutes. Should really check what time lunch finishes. 1320 minutes. Now, if you wanted to convert that into hours, you can just then divide that by 60. So I'm just going to do that on my calculator, divided by 60. That gives you 22 hours. Now, if you wanted to do that on the calculator, okay, so we found that point on the graph. So if we just go Control Add Page, add your calculator, what we can do is just type this in 0.72 times 20 squared. So remember, we're letting x equal 20 minus 1.2 times 20. And you get your 264. Divide that by 0.2 because you're working out the rate per minute. And then divide that by, rate per minute, and then if we divide that by 60, we get how many hours? So 22 hours. Beautiful, girls.